Hello everyone. Today I am going to discuss about the Dijkstra's algorithm for single source shortest path. That is, here the graph is given. Okay, the graph is given, and let A is the source. 1 is the source. Okay, 1 is the source, and we have to find out the shortest distance between every nodes in the graph from this starting node, that is source 1. Okay, that's why single source shortest path. Okay. So in our previous video we have discussed about the particular leveling of every nodes. That is, every node, let jth node have a level uj and I. It means jth node is accessed from ith node. That is, jth node's immediate predecessor is ith node. Okay, that's why the second parameter I and uj is the distance from I to j. Okay, so this uj can be written in this form: ui plus d of ij, where ui is the distance from our source node, first node, to ith node, plus dij, that is the weight of the edge ij. Okay, so using this spatial leveling, we have to label all nodes of this given graph. So let our first iteration, we start with the first iteration considering the source vertex. So the source vertex, the level is 0, null. Why this? Because the first parameter is the distance from source vertex to the particular vertex. Here the source vertex is 1, destination vertex is 1. That's why we put uj as 0. And second parameter, that is null. That is, our source destination vertex is 1. So the immediate predecessor of destination vertex is itself. That's why null. Iteration 1, the leveling is 0, null for the node 1. Okay. Now iteration 2. So in our iteration 2, we have to and in iteration 1 we are finding 0, null for source node, and we make this level for this particular node as permanent. Okay, so first we write iteration 2. So node number, its level and its status. So first node is 1. First node is 1, and its level is 0, null, and its status is permanent. Next, from this first node 1, node 3 and node 2 can be accessed. So node 2 and node 3. Okay, node 2 and node 3. So for node 2, what will be the appropriate level? So for node 2, that is, node 2 is accessed from first node directly. Node 2 is accessed from first node directly, and 0 plus the distance, that is 1, and it is accessed from first node. So 1, and its status is temporary. Why? Because there may be some better route starting from the source vertex. That's why we initially made the status of node 2 is temporary. For node 3, this can be accessed from starting node 1. So 0 plus 2, and it is accessed from 1, that is 2, 1. Okay, and its status is also temporary. Now, after the iteration 2, there are two temporary nodes, node 2 and node 3. Among these two nodes, node 2 has minimum level value, that is 1, and node 3 has level value 2. That's why we have to take the minimum level value node, that is node 2, and we have to make this node 2 the status to permanent. So in iteration 3, at the beginning of iteration 3, we make the status of node 2 as permanent. Okay, now node 4, node 5 can be accessed from node 2. So node 4 and node 5, this can be accessed from node 2. So this is 1, 1, and this is 2, 1. This is 1, 1. That is distance from source node 1 to this particular node 2 is 1, and this is 2, 1. So in iteration 3, node 3 also can be accessed from node 2. That's why you have to take another level for node 3, that is 1 plus 1, but from node 2. Okay. And for node 4, this will be 1 plus 5 from node 2. And for node 5, 1 plus 2, but from node 2. Both the status are temporary. Okay. So this is the scenario after iteration 3. But here this is 1 plus 1, that is 2, 2. But here there are 3 temporary nodes, node 3, node 4, node 5. Among these 3 nodes, node 3 has minimum level value, that is 2. Node 4, the level value is 6, 2, and node 5, the level value is 3, 2. So 2, 6, 3. So minimum is 2. That's why we have to make the status of node 3 from temporary to permanent. Okay. So in iteration 4 begins with temporary to permanent of node 3. Iteration 4. Okay. So in iteration 4, node 6 also can be accessed from node 3. That's why we have to introduce node 6. Node 6. So what will be the value of node 6? Node 3 has 2 level value. It can be accessed either through 1 from directly with the cost 2, that is 2, 1 is 1 level, or 2 is another level. 2 is another level. That is, it can be accessed from 2 also, node 2 also. So 2 1 or 2 2. Okay. So node 1 complete, node 2 complete, node 3 complete with the level. Now in node 4. Now in node 4, the value is, level value is 6 2. 6 2. Value is 6 2. Also this node 4 can be accessed via node 3 with the value 2 plus 2 4. 2 plus 2 4. 2 plus 2, but from third node. That is 6 2. If we access this fourth node via the node 2, the cost will be 6 2. Or if we access this fourth node via third node, then the cost will be 2 for our cost of third node, 2 plus the distance 3 4. So 2 plus 2, that is 4 3. For fifth node, we can reach via third node. So this can be 3 2 or 3 2, comma. For node 3, the value is 2. So 2 plus 1 and 3, that is 3 3. And for node 6, the values are, for third node the value is 2. So 2 plus 4 and 3, and make the status of 6th node as temporary. Okay. Now in iteration 4, there are 3 temporary nodes, 4 5 6. Among these, 5th node has the lowest value, 3. 5th node can be accessed either via 2 or 3, third node or second node. So after the completion of iteration 4, we have to make this 5th node as permanent. Okay. So what will be the value? In iteration 5. So 5th node will now become permanent with the value 3 2 or 3 3. 3 2 or 3 3. That is 3 2 or 3 3. And in 4th node, the values are 6 2 or 6 2, 4 3. Which one is minimum? 4 3 is minimum. So for 4th node, to reach the 4th node, we have to access via the 3rd node with the cost 4, and we have to discard this level 6 2, that is via second node. So the value will be 4 3. Okay. And for 6th node, this is 6 3. 6, 3. So in the 5th iteration. As the 5th node is made at the beginning of 5th iteration, as 5th node is made permanent, so 7th node can be accessed via 5th node. So 7, we have to introduce 7th node. 7th node and the temporary. Okay. So with the value, 5th node, the value is 3. So 3 plus 7, 5, that is 10 5. If we access the 7th node via 5th node, the cost will be 10 and the level will be 10 5. If we access the 6th node via 5th node, the value will be 3 plus 3 6. 3 plus 3 6. Okay. So 3 plus 3, 3 plus 3, that is 6 via fifth node. Okay. and here there are 3 temporary nodes. Node 4, node 5 complete, node 4, node 6, node 7. So node 4, so in node 4 the level value, so in node 4 the level value is 4, 3. Level value is 4, 3. And node 6, the level value is 6. Either 6, 3 or 6, 5. In 7th node, the level value is 10, 5. Okay. So we have to take 4th node as permanent in iteration 6. So in beginning of iteration 6, we have to make this 4th node. We have to make this 4th node as iteration 6, 4th node as permanent. Fourth node as permanent, okay? And the 6th node, the level value is either 6, 3 or 6, 5. Either 6, 3 or 6, 5. For the 7th node, the value is 10, 5. 10, 5. For the 7th node, this is 10, 5. Now, this iteration 6, in this iteration 6, this 6th node and 7th node can be accessed via 4th node with the cost for 4th node the value is 4 and 4 plus 6 that is 4 plus 6 and via the 4th node. Similarly for 4th node the value is 4 plus the distance 4 to 7 is 8. So 4 plus 8 comma 4. So in iteration 6 we can revisit 6 and 7 via 4th node with the cost 10, 4 and 12, 4 respectively. But for node 6 the levels 6, 3 and 6, 5 are less than 10, 4. That's why we can easily, node 6 can easily discard the path via 4th node. So this 10, 4 is discarded. Okay. In the same reason, node 7 can discard this value 12, 4 as 10 is less than 12. Okay. So after sixth iteration, there are 2 temporary nodes, 6 and 7. Among these two nodes, node 6 has lowest level value. That's why we have to make this 6th node as permanent. So we make this 6th node as permanent. And the level value is 6, 3 and the level value for 6th node is 6, 3 or 6, 5. 6, 3 or 6, 5. Okay. And for 7th node, the level value is 10, 5. That is via 5th node. Clear? Now, node 8 can be explored via this sixth node. Sixth node is made permanent. So what will be the value? So node 8, here I have written node 8 to the continuation of this node 8. What will be the level value? Initially node 8 is made temporary. What will be the value? So the value will be 6 as it can be accessed via the 6th node. So the value will be 6 plus the distance to, so 6 plus the distance to via 6th node, that is 8, 6. Clear? So among these two nodes, 7 and 8 in iteration, this is in iteration 7, 7th iteration. In iteration 7, there are two temporary nodes, 7 and 8. Clear? 7 and 8. So, among these two temporary nodes, node 8 has minimum level value. 8, 6, less than 10. 8 is less than 10. That's why we can make this temporary status to the permanent status. So, permanent status 8, 6. So 8 complete. So there is only one left, node 7. There is only one left, node 7. So we have to make this one left, node 7 to permanent. So we make this 7th node as permanent. Look carefully, there is another part 7, 8. There is another part 7, 8, but as the uj value, as the level value of 8th node is 8, this is less than the uj value of 7th node, that is the level value of 7th node, that is 10. So 8 is less than 10. 8 is less than 10. And the cost from 7 to 8 is positive. So we can easily, without any hesitation, we can discard this 7, 8 distance, 7, 8 weight. So this is the complete scenario. That is node 1, the level is 0 now. Node 2 can be accessed from node 1 with the cost 1. Node 3 can be accessed from node 1 with the cost 2, or node 2 with the cost 2. Similar way, the level values of node 4 is 4, 3, node 5 is 3, 2 or 3, 3. That is, node 5 can be accessed either via second node or via third node with the cost of 3. Node 6, the cost is 6, 3, level value 6, 3 or 6, 5. There are two ways. In 7th node, there is the cost 10, 5, that is, to access the 7th node, we have to traverse through 5th node, 10, 5. Similarly, in node 8, the cost is, level value is 8, 6. Okay? So this is the details execution of Dijkstra algorithm for single source shortest path. Here we take the single source as 1. Okay? Thank you.